All right, so today we're going to talk about industrial Ethernet. All right, so far in the past, we have talked about Ethernet. Our last few classes have been talking about networking and Ethernet. So, of the cables that we're making, like what you guys just made, what do you think the types of speed we can get? You guys remember? I know I mentioned this was like, my house, I have this speed between my server and this. You probably have no need for that. All right, most newer equipment is 1 gig. All right, right out of the box. If you got an Ethernet cable you're plugging into like your laptop to your home router or whatever, it's probably going to be about 1 gigabit. The old standard was 100 meg. All right, so there's lots of different options here. But up here on the screen it says base what? All right, and you can say we've got 10 base, 100 base, and 1,000 base. Well, the 10, 100, and 1,000, that's our speed. So is it 10 megabit, 100 megabit, 1,000 megabit, or gigabit speed? All right, and now you can see there's base 2, there's base 5, there's base T. Holy moly, the list just kind of goes on and on. All right. So just for example, base 10 base 2 is thin wire coax cable, which is only 6.3 millimeters in diameter, and this handles 10 megabits, and this was for bus topology. The 10 base 5, that was stick wire. That was about 13 millimeters, and that was still 10 base for bus topology. The list kind of goes on and on here. I'm not going to go through all of these because that just seems a little crazy to me. The one thing I do want to, I guess I'm going to point out some slight weirdities here. 2 and 5, those are both coax still. So that was the center wire with the sheathing on the outside for shielding. So that's more analog. All right. When we get the T, that is unscreened twisted pair. All right. So that's basically what we just made these cables out of, UTP, or unshielded. And then the F is for fiber optic. All right. So T twisted pair, F is fiber optic. We go to the wonderful world of 100 meg. Every TX is copper, FX is fiber, T4 is for Cat 3, T2 is still Cat 3, but these are never really that great. You get to 100 base X or 1,000. This is gigabit. SX is short wavelength fiber, LX is long wavelength fiber, and CX is copper. All right. So there are just different options out there. But if you ever hear someone talk about equipment that, oh, it's a 10 base, whatever, just know instantly that's a 10 megabit or 100 or 1,000 or something higher than that. All right. I don't know if I actually mentioned this, but said at home your standard is probably either 100 meg or 1,000 meg is what your like internet speeds are between devices, right, over Ethernet. Newer, like I'm gonna go with one for gaming, all right, or more industrial things. They're actually starting to come with 2.5 gig network cards built into them. Right. Now, if your home router doesn't support 2.5 gig and your motherboard and your computer does, you're still going to be at a 1 gig connection or whatever your router handles. All right. But just something to kind of think about for you, just to keep in mind. You can go up to 10 gig over, I think, like traditional home networks. So that is just something to kind of think about. So early Ethernet. All right, this, as you can see, is the coax connection. All right, if you didn't know that, that's one of the old coax. I believe this is actually it's either an SL or a PO 239 connector is what that looks like to me. And the only reason I'm saying that is its size. So the size pointing towards us, this, come on, here we go. That looks like I said it's either I'm guessing it's either an SO 239 or a PL. One of them is male, one of them is female. The only thing I'm questioning is this internal screw or code thing here. I'm not sure what's going on with that. Not used to seeing that one. But outside, I just like that. Oh, actually, I said this is an N-type connector, so I'm horribly off on either of those. Looks a lot like those. But anyway, so this was early Ethernet, all right? This has also become the de facto field bus technology, is what my note says. It says N-type. This is a fairly rugged connector. It is screw-based. Coaxial has already hit that one up. So, yeah, that's really about all I got going on there. Next, we go to our modern industrial Ethernet. I love this picture with the wires all spread out the end. And look, they even got them in the right order. Whoever made this followed the B standard. All right, so this is 10 base to 100 base. Again, RJ45. All right. All right, now this does say Cat 5 UTP, remember, unshielded twisted pair. And this says, despite its inheritance resistance to electromagnetically induced interference, unshielded twisted pair is not really suited for industrial applications. Right? Hence that green wire that I was showing you guys before this recording. or how it has that extra shielding on the outside. So the case here actually has metal on it, so it can be shielded into the switch or whatever, and then that connects to the outside of that coating. One of these days, I'll probably cut one of those cables in half so you can actually see that right into it. But we're come back to that one. All right. So the RJ45 connectors, they're not very rugged connectors, and this stupid retention clip is often known to break off. All right. Technically, you don't need that clip. All right. That clip is purely there to help keep the connector in. All right. I do have cables that have the clips broken off, and I still use them. They plug in just fine. They just don't stay in as well. All right. So you have to know to. Oh, why my Ethernet connection funky? You got to shove it back in a little bit farther, then your Ethernet connection will come right back. I don't suggest doing that, but it does still work. It's not like, oh no, that clip broke off, we're going to be down. No, it's, all right, I got to deal with this. All right. Also, I don't know about you guys. I don't have a good picture. The next page does. Come back to that in a minute. So anyway, yeah. So what we're moving towards is these types of connectors. All right. So you have the Cat5i. Oh, what I was going to talk about a moment ago was this piece of plastic here. All right, you guys have probably seen it on that green cable. It has it. Some of my white cables around. They have a little booty over the end of the connector. All right, that does two things. One is help with strain relief, because if you've got your connector here and you got your cable coming out of it, and then you put this silly little booty on it, so you got the release tab right here. And you put that little like booty on it. It kind of comes up like this. All right, it helps strain relief right at the end of the cable, so that'll help longevity of your cables if you're constantly pulling them in and out, plug in and twist in and things like that. So that is good. Also, typically those booties will go a little bit over that release tab, so that way you're less likely to break it off. So if you're, the reason I break mine off is I'm pulling my Ethernet cable past something and it catches, and I just keep pulling and it just bends it all the way around. So that little booty will help protect that. So a little bit of give and take going on there. But anyway. So we've got Cat5i, which is foil and braided shields for full RF and EMI protection. This is a tough, high flexible polyurethane jacket for longer performance life in harsh industrial environments. We'll come back to the whole foil and braided shield on the next slide in a minute. All right, we've got our D connectors. Okay, that'd be this one at the top here, right? It looks like a D, if you remember, kind of right there. All right, so AKDB or D-sub. We also have the M12 form factor, which I believe is that one. So this is widely accepted in the field bus and automation applications. If you look really closely, you could count the terminals. So there are 2 terminals per quarter, so there's 8 terminals in there. This does offer excellent protection against moisture, dust, corrosion, EMI, RFI, mechanical vibration, shock, UV radiation, and extreme temperatures. That's a mouthful. All right. That looks like a pretty ballsy connector, doesn't it? I think so. It's all metal. It's a twist lock. You can see the threads going on here. They've probably got waterproof gland on the end there. That's why you see more threads right here. So once you build your connector and you put it in, you screw that down, which cinches up on the sheathing on the outside to provide nice waterproof, dustproof connection. Helps again with some flexibility and things like that. So it's a really great connection. I should go buy a few of these, but I'm sure they're also priced through the freaking roof compared to our little plastic connectors that we just used the last few days. So there's always going to be that lovely give and take. Now, remember, when your boss is telling you, why do you need this $3 connector? It's like, well, I can buy a 30-cent connector, but I'm going to have to fix it or fight with it or whatever. I'm going to spend hours on this thing. Would you rather me not spend a $5 connector once and not have to spend time fixing this connector or having electrical interference or things like that? So always remember that argument when it comes to your boss asking you why you want to spend money. It's like, well, we can either spend money now or we can spend more money later with my time. Which do you want? And depending on your boss, they're going to go, yeah, your time is fine, because they don't have a budget for all these connectors. Where, some other bosses be like, I'll find the budget. Like, we're going to make this work so I don't have to spend your hours on this later, type of thing. Or your boss may go, put the cheap connector on it now, in a few months when I can get budget for this, then we'll buy a better connector and replace it. So, a little give and take going on. But, always remember those types of arguments. It's always, whenever someone's like, why do you need this expensive thing? Go, well, I can either spend a lot of time troubleshooting and fighting with this thing in the long run, or I can spend more money up front and save my, hours. And 1 hour of my time is worth $40. So if I spend 5 minutes a day over the next 2 years on this thing, my time's going to add up real quick for a $5 connector. So I always like to think of it that way. But anyway, so here we have almost all the different options when it comes to Ethernet cable. All right, at least on the internals. So we have up in the top here, this one is our UTP, our unshielded twisted pair. All right, now I'll give you guys some options. You have foil, you have shielded. All right, so what do you think this one is? Yep, that would be a foil. All right, that's FUTP. So it's foil, unshielded, twisted pair. All right, what about this one? One next to the right. What? Nope. So if you look really closely at this, it might be hard for you guys to tell, but there's some like paths here for all the wireless is like crosshatch going on. That's just going to be shielded. All right. So the foil is literally like, as far as I'm concerned, like aluminum foil, where it's one solid sheet that they just wrap, like kind of roll them up in. Where this one, it's actually braided. So they actually took these groups of wires, they braided those together around the outside. So that one's going to be shielded. And that's still unshielded twisted pair. Doesn't make a lot of sense, right? It's shielded, but it's unshielded. All right. And the key here is this shielding is around all of them. All right. And then we have unshielded inside of it twisted pairs. All right. What about this one, middle left? It can be both. All right. So if we look, we've got our shielding up to here, and then you've got your foil there. So this would be SF UTP. All right. Now in the middle, we're getting a little bit fancier. Nope, no shielding. Just unshielded foil twisted pair. So this would be UFTP. So we have the foil, but now the foil is going around each individual set of twisted pairs instead of around all of them. All right, so you can see how there's a slight difference there. All right, but that shields things differently, so a little give and take. This one out here, the right. Yep, F/FTP. Make that better. All right, so we got each twisted pair individually, again, is foiled, and then we've got foil going around it. All right, at the bottom. Yep. SFFTP. So you've got shielding, you've got foil, and then you've got foil again. All right, and there is another one which I couldn't find a picture of, which is shielded foiled twisted pair. So instead of having the foil here, you would have that shielding, like hash pattern. All right, so a little bit of give and take again when it comes to all of these things. But there's a lot of stupid different types of Ethernet cable. All right, and this probably goes for, well, I said what we're using, I think was Cat 6 cable. What's up? They should be all, I should have slashes everywhere else.
Oh, okay.
I just didn't put it in. All right, and I don't know if that slash is actually important. It's just how my notes have it. So, yeah, the slashes should really be everywhere. I think the slash is basically denoting that the shielding is not around the twisted, whatever before the twisted pairs. So I think that's really what is going on here. All right. But yeah, so I think, and again, looking like this one, you can see there's that plastic core inside of it. None of these other ones are showing us that plastic core. So I don't know what's going on. But yeah, there's a difference from Cat 5 cable to Cat 6 to Cat 7. I think we're up to Cat 7 Ethernet cable nowadays. All right, and theoretically, there is an absolute maximum speed based on different Ethernet cables. So like a Cat 6 cable technically has a higher max speed than a Cat 5 cable does. All right. So there are some problems and things that you have to deal with that, but to each a little bit of give and take going on is what it comes down to. All right, now latency. What is latency? Give me your best guess. Yep. All right. So it's if I say something, how long does it take to get from me to you? All right. Now, very little right now, right? I don't know, the speed of sound, I guess. I don't know how long, and that's stupid fast. But if you ever talk to people who are on broadcast radio or something like that, or if you ever doing something where you have headphones on listening to yourself talk, every once in a while it will get off. All right, and there's actually an app for that where you can talk into your microphone and then you'll hear it back yourself delayed. And trying to talk like that is actually very difficult because we're so used to talking and hearing ourselves instantly. Where if you have all of a sudden that you have that being delayed by a millisecond, 5 milliseconds, whatever. Exactly. You're trying to talk and you're like, you just keep hearing it just a little delayed and just you kind of have to just ignore what you're hearing and just talk type of thing. But anyway, when it comes to latency, certain applications are important, certain it doesn't matter. If you're downloading a file, latency really isn't that big of a deal, you know. As long as you've got relatively good latency, it's like, okay, I can download the file, my computer can put the packets in the right order, everything is fine. But when it comes to anything real time, latency becomes very important, right? So whether you're gaming or you're in an industrial environment, latency is important for you. So this says the first thing, oftentimes industrial processes require 5 to 20 millisecond range. So if your latency is more than 20 milliseconds, that will cause problems. All right, for example, it's like, okay, we're trying to make shampoo, and you know, we have a sensor that's going to tell us when the tank is full, and we require a very specific ratio of, you know, fluid A to B to C. And if we're saying, okay, now fill till tank is full, and that we don't get that signal for 2 seconds or whatever, there's now an extra gallon or 2 gallons of liquid in there, and that completely screws up the ratio. Now, maybe shampoo is not a big idea, but if you're going with like something like cookie dough or something, you know, now the flavor is going to be different. All right, so you got to take those types of things. Like there is a need for low latency for certain things. My notes say that for really demanding processes, that could even be down to 2 to 5 milliseconds. All right, and if you guys remember, we talked about last class, we talked about UDP versus TCP. Which one was the one that requires a handshake? TCP requires the handshake. UDP does not. UDP is better for industrial purposes because of that lower latency. It's just, hey, we're full. Just send it out there. Whoever gets it, gets it. I don't care. But we're full. Don't go, hey, are we full? Oh, yeah, we're full. Thanks, buddy. No. Just send out we're full type of thing. All right. So that's where that UDP comes in and it's very important. All right. Now, the other thing is how clogged up are your networks? All right. So that's what we're talking about here with this 25 to 30% is acceptable. All right. If you have networks. Now, mind you, when you have a network and you're saying, oh, I have a 10 megabyte network, I'm trying to send a few bits of information. 10 meg is plenty fast for that, right? But if everybody's sending all this information, and now that channel is full, so that 10 meg is full, even though we're trying to send a few bits, now you have to wait your turn to send your message. Now that 10 meg is not enough. All right, so even though we're not transferring a lot of data, there's a lot of messages being sent back and forth from one device to another, you can saturate your computer network. Right? So we need to keep our utilization lower. All right. Yeah. All right. So anyway, I up here have on the screen, it says 25 to 30%. Some utilization less than 10% is normally maybe 3 to 4. All right. So now I will say the other thing I have here is that the advent of fast and gigabit Ethernet switching hubs, VLAN tech, and full duplex operation and real-time, you know, communication has effectively put this concern to rest for most applications. So it's not as big of a deal now as it used to be. All right, now that we've got full duplex, so we can transmit and receive at the same time, being able to segregate our networks, right? So we can say, oh, you know, instead of broadcasting, you know, every time I broadcast a message out that goes everywhere, we have the switches instead of hubs. So the hubs broadcast it everywhere, a switch goes, no, with just this one port. It is dropping our utilization. It is reducing the load on our network. So by doing that, it helps out a lot. So a little bit of give and take going on there. So that solves a lot of problems. So, and just higher speeds. So even though we're only sending little bits of information, having much faster transmit lanes, we're using that lane less, so it means we can have faster latency, lower latency. So that is going to be extremely important. All right, and then other thing is the size of the overhead Ethernet frame. You guys remember I showed you that frame last class. It was like, oh, here's all the information. It's like, this is just the header. It's like, that's a lot. So if you only need to send 2 bytes of data, but the minimum message size is 60 bytes, you're transmitting a lot of nothing. All right. So it's just, again, one of those things that you have to think about. Again, hopefully not you're thinking about, hopefully that's the IT people. You're going, hey, my data's not getting here quick enough. How can we solve this? And they go, okay, we'll add a redundant loop path, or we'll add an extra path, that we're doing this, or we'll segregate you guys onto this network, or whatever the case is. But that shouldn't really be your job to figure that problem out. It should be your job to figure out that latency is the problem, and then it should be IT's job to solve that. Remember I told you, the more you can befriend IT and go, hey, I think we're having this problem. Can we put a dedicated path or something in? We're happy they're going to be and willing to help you. So I always like to think about that. All right, and then the other thing I have up here is partitioning. All right, now we've talked about VLANs and things, and we've talked about VLANs. How if you're on the Wi-Fi network here, it's the same as being on the Wi-Fi network in a different building. All right, all of our projectors are on the same VLAN. So if I open up the app on my phone to share my screen from my phone to the projector, it actually gives me all of the projectors on campus that are on. Now, there is a code I have to type in that the projector displays, so it's not like I can just be like, I'm going to interrupt Ed Bass's class instead of No, I can't do that because I need the code off the screen. But they're all in the same, so it doesn't matter that I'm in this building. I could be projecting to a projector in a whole different building. All right. So network partitioning is nice, but it's also there for security. Right? If we take all of our, if you have a 100-person company, that includes your finance people and your HR people and your industrial network and everything, and everyone's on the same network. And company B says we want to sabotage company A, and they get buy someone out in HR with the industrial network. There's no reason the HR person should have any access to the industrial network. So by segregating our networks correctly, we're now making better security. Right? Some things security is a big issue, a very important thing. All right. This also does decrease the speed or increase our speed and response times because again, we're not broadcasting to the entire network. We're only broadcasting to a portion. That's what matters. Some PLC manufacturers use what's called exception reporting. So when they're saying, hey, this sensor has changed, all right, instead of saying, hey, here are all my inputs, here's what's changed, no, they're saying this one sensor has changed. And that again reduces our times and things like that. And then the other thing is switches. We've already talked about those, but those are necessary for latency. Not broadcasting everywhere, congesting the network. They're broadcasting to a specific port. So they're going to be very important. Now, I want to come back to this. We'll come back to the application layer. All right. So some different industrial Ethernet protocols. All right. So we have the standard software standard Ethernet. So this uses standard Ethernet with the TCP/IP protocol. All right. So everything is standardized about this. We just build mechanisms on top of the application layer for the real-time communications. So that's going back more to the UDP type of thing than TCP. All right. You have the open software standard Ethernet. So this uses the standard Ethernet layers with new standard protocols that manage the access to the network. So we have synchronizing the data being sent from each node to ensure priority data sent first. So that one's that one. So we're modifying the OSI model a little bit here, but you can still use standard Ethernet everything. So like switches and hubs and routers and all that stuff, everything would work just fine. And that takes us to the open software modified Ethernet. So this is based on standard Ethernet hardware, but it uses new protocols and additional complementary hardware to ensure determinism. So we're getting everything where it needs to be when it needs to be there. Now, this may or may not work with standard Ethernet hardware. That's where the fun comes in. All right. I love standards. I love it when I love open standards because that means everybody can make whatever device they want and they can make everything communicate how it's supposed to. Right? I hate standards that are closed off or proprietary, things like that. So it's like, hey, I want to add this capability. I'm like, no, man, you can't do that. I'm like, what are you doing? All right, kind of drives me nuts. So, but anyway, so those are some different ones. Here we have that OSI model again. We talked about, I think briefly last class, or 2 classes ago. I don't remember which one. But they're just showing you here for the Ethernet IP system. The Ethernet portion would be the bottom 2 layers. All right, we will come back to the OSI model. Don't worry. So Ethernet and Ethernet's the bottom 2. TCP/IP are 3 and 4, and then the CIP is the top 3 layers. All right, so they're we're using them all still. Again, this OSI model is just going to come bite us all in the butt. I absolutely hate it. overall very confusing, but it is a necessity for how everything works. So some different examples of industrial networks. We have Ethernet IP. So IP is the industrial protocol. This performs at levels 5, 6, and 7, which is the CIP, or the Common Industrial Protocol. So we have Ethernet packets used with industrial protocol. Yep, and then we're going to promote consistent implementation. Some other examples, we've got Profinet, we got Modbus TCP, you've got Foundation Field Bus. The list kind of goes on, is what it really comes to. And to me, Ethernet is just replacing all of these old, outdated, not even outdated, just these older networks for, again, consistency, for the hardware costs, those types of things. Ethernet has just become so reliable. If you think about it, we're basically relying on Ethernet to go from our houses to the internet, all the other fun stuff. And this whole OSI model and Ethernet and things like that it's getting our information from point A to point B. And that point B could be a server in freaking Germany. But it's still getting us from here to there and our information back to us in a relatively acceptable amount of time. So the OSI model is very secure. It's, I don't know about secure, but it's reliable is really what it is. It's also nice because your IT people understand it. Right? If you go to some of these more weird ones like Profibus or something like that, IT's gonna be like, what is this? We have no part of that. That is not part of the industrial technology network. That is not our deal. That is all you. So you now have to be an expert on it. Or if we start moving to the world of Ethernet, you can go, hey, what do you guys suggest for Ethernet equipment? And they can start saying, oh, we like these switches and this because of this, and we've never had a failure. And it's like, okay, cool. So our network at least is going to be up and running constantly. Not necessarily the PLCs, but the network. So a lot of give and take going on there. Any major questions on what I talked about today? No? All right, well, that would be the end of this lovely presentation.